Algebra 2 students, in this video today we'll be looking at 5 properties of exponents, okay? 5 properties of exponents. Your heading today is properties of exponents, and the lesson number is 7.1, okay? Properties of exponents, lesson 7.1, and as always, I would strongly encourage you to include today's date, alright? Alright, let's continue on. Now, I would not be exaggerating at all to say that you will use these properties for the rest of Algebra 2, pre-calculus, and other levels of math. All I can say is please learn these properties well. Master them. It is really, really important you get these properties. Here's property number 1. Please copy this down. I would encourage you to pause the video and copy it down. I'm going to move on like I do, remember. I always move on, that way you can pause it and move at your own pace. Property number 1. When multiplying like bases, and by the way, some of these will be reviewed from Algebra 1. When multiplying like bases, write the like base once and add the exponents. When multiplying like bases, write the base once and add the exponents, okay? Please copy that down. I'm going to move on to our examples. Here we go. Let's start off with a really simple example here, okay? Really simple. I would like to point out to you, copy this in your notes please, pause the video all that you need to. I would like to point out to you that in this part of the problem right here, the -3 is your what? Your base. And the 2 right here is called your exponent. Or we can also call it a power. Now some books call this entire expression altogether a power. I don't make that differentiation. I just simply say this 2 right here can be called a power or exponent, and this is your base right here. Okay, so with that in mind, notice that I'm multiplying. Do you see that? Everybody see that? And my base is -3, and my base is what? -3. So I'm multiplying like bases. Do you see that? Multiplying like bases. What do? You write the base once. So what's my like base? -3. So write it how many times? Once. And then do what? Add the exponents. So that's simple, guys. It really is. Exponent, exponent, add them together. There you go. Now, I'm well aware of the fact with the calculator you could have typed this in and typed this in, hit multiply and got out the answer, but on a test or a quiz I'm probably going to ask you to write your answer with powers or with exponents, okay? Now, in your book, I don't have a calculator with me. Well, in your book, okay guys, now in your books, listen, they're going to want you to take this to the next level. So in your calculator you would type in parentheses -3 parentheses, then hit your arrow button, and then hit 7, then hit enter, okay? Make sure you put your -3 in parentheses, and you'll get -2,187. So in your homework over this lesson, lesson 7.1, they are going to want you to take this a step further. But I want you to understand, on a test or a quiz, I might ask you to stop right here. So do not think that you can type this into your calculator, hit multiply, and get this and be okay. I'm the type of teacher that's going to make you, for your own benefit, because I care about you, I'm going to make sure you know these properties, okay? So anyways, if I ask you to write your answer with the power, you leave it like this. If I ask you to simplify as far as you can go, then you would take it a little further out to this number here. Alright, let's try another one. Alright, let's take a look at this one here. Now, this is kind of a trick problem here. What is my base? -3. What is my base? 5. Are they like bases? No. Okay? So since they're not like bases, you cannot use that property. So you'd have to simply say, okay, -3 squared. -3 squared is +9. 5 to the 3rd power is 125. And then multiply those together, and you will get 1,125. cannot use these properties, okay? Alright, let's move on and try another problem. Now, we have 3y squared times 2y to the fourth. Now, notice first of all that we're multiplying, okay? Now when you're multiplying, notice first of all that we're multiplying 3y squared times 2y to the fourth. Now, you can multiply your coefficients, okay? So 3 times 2 is 6. That's what you need to do. But now look at your y's. You have a base of y, a base of y. They are like bases, so you write the base once. And then what do? Add the exponents. 2 plus 4 is 6. And you're finished. Got it? Now, let's pretend for a second that this was an x right here. Okay? Here's what you would do. 3 times 2 is 6. You have an x here. Do you have an x over here to multiply with this x? No, you don't, so bring it down. You have a y here. Do you have a y over here to multiply with this y? No, you do not. And so there's your answer. Do you see the difference? I hope that you do. Okay? Alright, let's try another problem, and then we'll move on to another property. Alright, here we go. 2 times 4 is 8. Now, x times x. Now, there's no exponent here, so you can put a 1 there. Please understand that if there's no power or no exponent, you can put a 1. Now, look at your x's. Okay, guys, we have an x times an x. They're like bases, so write the x once. Add the exponents. What's 1 plus a negative 3? Negative 2. It's okay to have a negative exponent. We're going to move on to property number 4, and we talk about negative signs there, okay? Alright, now, so for now, let's not worry about it. Now, you have a y times, oh, there's no y over here, is there? So just put y squared. Now there's an a over here. There's no a over here to multiply with this a, so bring down your a, and you're finished. That's it. Now, some teachers want these put in alphabetical order like this. I am not at all worried about that. They're all multiplying, so it really doesn't matter what order they're in my opinion, okay? So either one of these two answers would be sufficient. Alright, guys, this is a property you need to know. Moving on to property number 2. Please copy this down. When dividing, so now we're switching gears. The last property was multiplying. Now it's dividing. When dividing like bases, write the like base once. Where? In the numerator. And take the top exponent. That should be minus the bottom exponent. When dividing like bases, write the like base once. Where? In the numerator. And take the top exponent minus the bottom exponent. Alright, here we go. Let's take a look at these problems. Again, pause the video whenever you need to. I move on. Pause the video. That's what you're supposed to do, okay? That's one of the benefits of a video class, so take advantage of it. And pause the video when you need to. Okay, we have an x divided by an x, so we have like bases. So what do when you're dividing like bases? You write the like base once. Where? In the numerator. So put your fraction bar and put your x up top. That's your like base, isn't it? What's your base here? X. What's your base here? X. They're like. When you're dividing like bases, write the like base once in the numerator. Next, take the top exponent 2 minus the bottom exponent 5. So 2 minus 5, negative 3. Now there's nothing left in the denominator. You can put a 1 if you want to. I have no problem with that. Or you can just say x to the negative 3rd power. Okay? Alright, moving on. Let's take a look at the next problem here. Now, this is similar to the last problem, except now we're throwing in some more variables or letters. And now we have some coefficients here, okay? So, first of all, take care of your coefficients. 2 divided by 4, well, we're just going to reduce that, okay? So, x right here. Is there an x up top to divide with this x here? No, there's not. So just leave your x there. Now, I have a y up top and a y in the bottom, correct? That's called dividing like bases. What do you do when you're dividing like bases? You write the like base once in the numerator. So write the y up top. And then take the top exponent, 3, minus the bottom exponent, 1. 3 minus 1 is 2. Now, that is a perfect answer. If you don't want to put that 1, you don't have to. You can just write this if you want to also. I have no preference, okay? There we go. Alright, now, I need to stop and say something to you students right now so that you're not confused. Let's go back and look at the last problem we did. What I have to say right now is so important. Are you ready? If we would have had two terms up here like this, 5 plus x over x to the 5th, you cannot use this property, okay? You cannot use it. You can only use this property when it's one term over one term, okay? Very important that you understand that, all right? Same thing with the second problem. Sorry about that. Same thing with the next problem here. That we did. If this would have been 2 plus y cubed, you could not use this property. If it was 4 plus xy or 4x plus y, that's two terms, you could not use this property. You can only use this property when you have one term up top and one term in the bottom. Remember, positive and negative signs are what make an algebra expression or what divides an algebra expression into terms, okay? Don't forget that. This is one term because there's no positives or negatives, and this is one term because there's no positives or negatives, okay? Alright, moving on. Next problem. Now, I know that with your calculator, you can type this whole thing in and get out an answer, but remember, on a test or a quiz, I'm going to make you write your answers with exponents. Now, in your homework for this lesson, they want you to work it all the way out to one number, okay? So we're going to do that, but we're still going to use our properties. Now, first of all, I have a 6 and a 6 and a 6. Now, look, simplify the numerator first. I should not have to tell you that. That's common sense, guys. Why would you want to try to start dividing when you've got two 6's up top? So look, I have a common base, right? Let's go back to our last page. When multiplying like bases, write the base once and add the exponents. So I have 6 squared times 6 to the 1. I'm multiplying these two 6's. Here's my base, they're like. So write the base once. 2 plus 1 is 3. There, I simplified the numerator. Bring over your denominator. Now, I'm dividing like bases. What do you do when you're dividing like bases? I have a base of 6 and a base of 6. Well, you write the like base once in the numerator. So my like base is 6, write it in the numerator, and then you take the top exponent, 3, minus the bottom exponent, 5. 3 minus 5. Now there's nothing left in the denominator, so we're going to put a 1 here. That's a fine answer. Or you can put 6 to the negative 2. Okay? Now if you type that into your calculator, you're going to get 1 over 36. You would type it in like this. You would type in 6 arrow negative 2. Okay? If you type that in, you're going to get 0.0277777778. Just hit math, enter, and you'll get this fraction here. So you're welcome to put this for an answer, or you're welcome to put the decimal form. 0.027 with a 7 repeating. Okay? Either one of those two are fine. But on a test or a quiz, I'm probably going to have you write your answer like this so that I can see that you're using these properties. Alright, let's move on to the next property. And here we go. Alright, so we're going to mix a bunch of stuff together now, okay? First of all, we're multiplying top times top, okay? So we have this term here times this term here. Okay, so here we go. 4 times 5 is 20. We have x times x. We're multiplying like bases. So write the base once, add the exponents. Next, y times y. We're multiplying like bases. Write the y once. There's a 1 here and a 1 here. plus 1 is 2. Now we're going to multiply the denominator times the denominator, okay? I'm not sure why I put this. Should be one fraction. Alright, there we go. Now, there's a 1 here, even though you can't see it. 1y cubed, so 10 times 1 is 10. I have an x here, no x over here to multiply with it, so leave it the same. I have a y here, no y over here to multiply with it, so leave it the same. And now let's simplify this and we're finished, okay? Now, 20 over 10, well, we can reduce that. 10 goes into 10 once, 10 goes into 22 times. So I now have 2 right here and 1 right here. Now, we're dividing like bases. Do you see that? X divided by x. So when you're dividing like bases, you write the like base once. Where? In the numerator. And then you take top minus the bottom. 6 minus 2 is 4. Now, dividing a y by a y. When you're dividing y minus y, when you're dividing like bases, you write the like base once in the numerator. And 2 minus 3 is negative 1. Okay? So you're welcome to leave your answer like this if you want. 2x to the fourth, y to the negative 1, all over 1. That's fine. Or you're welcome to just have the 2x to the fourth, y to the negative 1 would be totally fine. Okay? Whatever you want to do. Alright? Okay? Property number 3. Please copy this down. When a power is raised to another power, multiply the exponents together. Very simple. When a power is raised to a power, to another power, multiply the exponents, okay? I'm going to move on. Pause the video if you need to. Okay, let's take a look at our first example here. Now, notice I do not have x squared times x to the fifth. If I did, I would have two different, well, they're the same, I would have two bases. Even though they're like, I would have a base here and a base here. So my answer would be x to the what? 7th. That's not what I have. I have one base with how many exponents? 2. So when you have a power raised to another power, you multiply the exponents. There's your answer. Plain and simple. Piece of cake. Okay? Do you see it okay? X squared to the 5th power is different than x squared times x to the 5th. Here we have two bases with their own powers. Here I have one base with two powers. Alright, let's try another one. Let's look at it again. When a power is raised to another power, you simply multiply the exponents together. Okay? Let's take a look at this one over here. Now, here I have an entire group being raised to a power. Okay? Now here's where students sometimes get confused, but if you'll listen carefully and watch carefully, you'll be okay. Even though you can't see it, there's a 1 right here, 3 to the 1 power. And even though you can't see it, there's a 1 here with the x to the 1 power. Now, all of these powers are being raised to the 2nd power because all of these powers are inside the parentheses. Okay? So here we go. You multiply the exponents. 2 times 1 is 2. 2 times 1 is 2. 2 times 4 is 8. Now we're almost done. There's nothing you can do with these two, with the x and the y, but 3 squared is 9. So your final answer is 9 x squared, y to the 8th. Now, I want to be very clear. If there would have been a positive, are you listening to me? Listen, guys, if there would have been a positive sign here, I would have had two terms. One term here and one term here. Or, if there had been a plus sign here, I would have had one term here. Well, that's two terms. Or, I might have had three terms. This here and this here. A plus and a minus, that's three terms. This property does not work. It does not work unless you have one term being raised to a power. So if you have x plus 5 being raised to the 2nd power, you cannot put a 1 here and a 1 here and multiply the 2 through and write x squared plus 5 squared. That is totally incorrect because you have how many terms right here? 2 terms. This property only works when you have one term. Got it? Don't forget that. couple seconds here, but hold on, be patient with me, okay? This problem here, if I would have had x squared plus 1, you cannot take that 5 and multiply it through. That's two terms. Please understand that, students, okay? This property only works when you have one term being raised to a power. Now, you look at this, you're like, oh, Mr. Eric, this is two terms. Not at all. Not a bit. A fraction would be the same thing as a decimal, like 0.6 repeating, being raised to the third power. This is not two terms. This is one term. So you can put a 1 here and a 1 here. All of these powers are being raised to a power. 3 times 1 is 3. 3 times 1 is 3. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Let's move on, students. Your final answer here, 8 over 27. Okay, last problem in this, for this property. Okay, we have an entire fraction being raised to the third power. Okay, so I've got a 1 here, a 1 here. If it helps you to write these ones in, don't feel dumb, do it. Okay, it's fine. All right, here we go. So take your 3 and multiply it through. 3 times 1 is 3. 3 times 1 is 3. 3 times 3 is 9. 3 times 4 is 12. Now, denominator, 3 times 1 is 3. 3 times 3 is 9. 3 times 2 is 6. Now, let's work with our coefficients. 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. Does any number go into those evenly? I don't think so. I'm trying to think here. No, it cannot be reduced. So we're going to leave our numerator with a 27 and our denominator with a 125. Now, okay, we're dividing like bases. We have an A here and an A here. So when you're dividing like bases, you write the like base ones in the numerator. 3 minus 9 is negative 6. Cross those off. Now to your B. There's no B down here to divide with this B, so leave it up top. Onto my C's. I have a C divided by a C. I'm dividing like bases. Whenever you're dividing like bases, don't forget your last property. Write the exponent once in the numerator and take the top minus the bottom exponent. So, write your base up top. 12 minus 6 is 6, and you're good. Of course, it looks like the fraction's going to fall over. So I guess for cosmetic reasons, we'll move this over here. And there's our answer, okay? Alright, moving on. Don't worry about this negative exponent. We're getting to that in our next property right now, okay? So here we go. Please copy this down. Pause the video if you need to. An exponent sign, not the base. My goodness, over and over every year I have something like this, and students are like, oh, I can use this property to change this sign. Really? I don't think so. Look at this. An exponent sign can be changed. Not a basis sign. Not the base. Okay? Get that drilled into your head, guys. Alright. An exponent sign, not the base, can be changed. How? By moving the exponent and its base from the numerator to the denominator, or from the denominator to the numerator. Now, that sounds like a bunch of gibberish, okay? But let me show you what this means. Now, I'm going to move on. Pause the video and copy that down if you've not done that yet, okay? Alright, first problem. Alright, here we go. What if I asked you, let's say this, let's say for the rest of this video, whenever I ask you to simplify expressions, that means you want no negative exponents. So if I were to go back to this problem here in your notes, see this a to the negative 6, I would cross it off and bring it down to the bottom, and that would make the negative 6 become a positive 6. Okay? So your final answer would be 27, b to the 9, c to the 6, over 125, a to the 6. Alright, now, listen carefully. We've not gone over this yet, but I'm just saying, let's pretend from now on, and I would not change your answer right here. I'm just showing you that from now on, starting with this problem here, right here, from now on, I want all of your answers to have positive exponents. Okay, so here we go. There's really nothing I can do. there's a coefficient here, 1, but I really can't reduce 3 over 1. There's a y, there's an x here, but no x down here to divide with. There's a y here, but no y up top to divide with. There's really nothing I can do but hold it. An exponent's sign can be changed. So see this exponent right here. What is it, positive or negative? It's negative, right? Okay. I can change that. How? Are you reading? Read carefully. You move the exponent and what else? Its base. So what is the exponent I'm trying to change? That one. What is the base? Not the 3, not the y. What's the base of the negative 2? X. So I'm going to move the x and the negative 2 to the bottom. Now what's already in the denominator? A y. What am I bringing down? An x. What happens to the negative 2? Becomes a positive 2. What's left up top? 3. Now that's it. We're finished, okay? There's nothing else I can do. Now, what's here even though you can't see it? A 1. What if I wanted you to write everything in the denominator? Okay, no problem. Bring the 3 down here, and when you do, that 1 becomes a what? A negative 1. Look, guys, look carefully. An exponent's sign can be changed. That means it changes from negative to positive, or from positive to negative, just simply by moving the exponent and its base from the numerator to the denominator, or from the denominator to the numerator. So I could move this 3 back up if I wanted to, and the negative 1 would become a positive 1. Notice the 3 never changed. 3 is positive no matter what. The x never changed. The x is positive. Now, this property, students, I care about you so much. I know the mistakes you're going to make. By the way, there's your answer. We're finished. I know the mistake you're going to make. So please listen to me. You cannot use this property if there's 2 terms up here, more than 1 term up here, or more than 1 term down here. You can't. So if there's a positive sign here, you cannot bring that x to the negative 2 down. You cannot do it. Okay? Now there are exceptions to this we'll get into later, hopefully, but for right now, this property only works when you're dealing with 1 term over 1 term. Okay? Very important you remember that. I would write that in your notes somewhere. Okay, now let's take a look at this one. Well, we learned back here in our third property that when you have a power raised to a power, you multiply the exponents. We have, a 1 right here and a 1 right here. So we have these 2 powers right here being raised to the negative 3 power. So we're going to multiply our exponents. Negative 3 times 1 is negative 3. Negative 3 times 1 is negative 3. Now, if I take this 3 right here with its negative exponent and bring it up top, I will have a 3 to the positive 3. Notice this 3 right here did not change. The base doesn't change. The exponent sign can be changed, not the base. Okay? This 2 to the negative 3, what has a negative exponent, doesn't it? So I'm going to bring this down to here and make it 2 to the positive 3. There we go. See how easy it is to change the signs of your exponents? It's really, really simple, guys. Now to finalize the problem, 3 times 3 times 3. 2 times 2 times 2. You could write your answer like this. I have no problem with that. You could write your answer like this if you wanted to. 3.375. Or you could write your answer like this. 3 and 3/8. Any of those answers are good, okay? Alright, moving on to the next example. Alright, students, let's take a look at this example here. Now, I would not recommend getting rid of your negative exponents right away. Just go through all of your progressions like you should. First of all, we're multiplying 2 expressions together, so coefficient times coefficient, 2 times 4 is 8. Now, you have an x times an x. You're multiplying like bases, right? The x once. You have a 1 here and a negative 3 here. Add your exponents. I have a y squared, no y over here to multiply with it, bring it down. I have an a here, no a over here to multiply, bring it down. Now, remember, from now on, for the rest of this video, I do not want you to have any negative exponents in your answers, okay? No negative exponents in your answers. So, with that in mind, and hold on 1 second, I have a problem here with the headphones here. Okay, there we go. Now, with that in mind, what is my exponent of my 8? 1. What is the exponent of my y? 2. What is the exponent of my a? 1. Guys, students, dudes, all of these exponents are what? Positive, except this one. So you only need to move one thing. Don't move this, don't move this, don't move this. Put a fraction line. This thing's really all over what? What's it really all over? Come on, you guys know. 5 is the same thing as what? 5 over what? 1, you know that. So this whole expression is really over what? 1. So, here's your 1. Bring your x down to the bottom, and the 2 becomes what? Positive. Leave the 8 up top. Leave the y squared up top. Leave the a up top. Now, if you don't want to put this 1 here, you don't have to put that 1. I have no problem with that. Get rid of it or leave it. It's up to you. But there's your answer. How do you know you're finished? Well, first of all, what's your coefficient here? 1. Can you reduce 8 over 1? Not at all. You have a y here. Is there a y down here to divide with it? No. You have an a here. Is there an a down here to divide with it? No. You have an x here. Is there an x up here to divide with it? No. You're finished. Okay? Alright, let's try one more. Then we'll go on to our last, but not least, wonderful, beautiful, mathematical property. Alright, here we go. Now, we're multiplying two fractions together, so here we go. Top times the top. What is your x? What is your coefficient here? 1. 1 times -7. -7. Y to the 9th times y to the 1. You're multiplying like bases, right? The base once. Add your exponents. -8. Now denominator. Coefficient times coefficient. That would be 63. Y. There's no y over here to multiply with it. There's an x. No x over here to multiply with it. So there, we've done our multiplication, okay? Now we're going to do our division. Are you with me? We multiply. You might say, Mr. Harrod, wait, we've got negative exponents, guys. I would always recommend you save that for last, okay? Now, some teachers would teach otherwise, that's fine. Whatever, but I just like to save that for last, okay? Now, first of all, notice I have a negative over a positive. Well, a negative over a positive makes the whole fraction become what? Negative. Now, 7 goes into both these numbers, so this becomes a 1, this becomes a 9. So I have a 1 and a 9, okay? Both of these numbers are reducible by 7. Now I have a y being divided by a y. When you're dividing like bases, right, the y once up top, and take the top minus the bottom, so -8 minus what? -2. Well, -8 minus -2 is -8 plus 2. That's -6. Now, what do you have in the denominator still left over? X to the -5. There's no x up here to divide with it. Now, normally we'd be done, but I told you I want no more negative exponents in your final answer. So, here's your final answer. -1. We have 1 over 9. Now, bring your x. You would not move the 9, students, because the 9 has a power of 1. That's positive. You would not move this 1 because 1 has a power of 1. That's a positive exponent, okay? But the x has a negative exponent, so bring the base and the exponent up top, and the -5 becomes positive. This y has a negative exponent, so bring the y to the bottom, and the 6 changes. Notice the bases did not change, just the exponent. And there we go. There's my answer. Okay, guys. Alright. We actually saved the easiest for last. Here it is. Copy this down, please, in your notes. Property number 5. When a base has an exponent of 0, the base and the exponent together equal 1. When a base has an exponent of 0, the base and the exponent together equal just 1. Really simple. I'm going to move on. Pause the video if you need to. Alright. X to the 0 power. X to the 0 power. Now watch. If I have x to the 0 power, then the base and the exponent together, this whole thing just equals what? 1. Boom. Done. Finished. Anything equals 1. Let's take a look at this problem here. 2y to the 0 power. Now hold it. Don't say, oh, 0, 1, finished. Booyah. No, hold on a second, okay? Hold on a second. What's the power of the y? 0. But what's the power or the exponent of the 2? 1, so be careful here. I have 2 to the 1 power, which is what? 2, right? Now they're side by side, so they're really multiplying, right? Times, now what's y to the 0 power? Well, anything to the 0 power is just what? 1. Do you see how I did that? 2 to the 1 power is 2. Anything to the 0 power is 1. 2 times 1 is 2. Look at that. There we go. Okay. So one more problem and we're finished. Now, this problem here can be done two different ways. The fast way is this. You have an entire expression that's like one big base being raised to the what power. So your answer is just 1. But for those who want to work it out, let's work it out, okay? Here's what you've been taught so far. When you have powers being raised to a power, you multiply them together, okay? So here we go. I've got a 1 here and a 1 here. 0 times 1 is 0. 0 times 1 is 0. 0 times 2 is 0. 0 times 4 is 0. 2 to the 0 power. Remember, they're all multiplying. They're all multiplying. 2 to the 0 power is 1 times a to the 0 power is 1 times b to the 0 power is 1 times c to the 0 power is 1. 1 times 1 times 1 times 1 is 1. You can do it a fast way or a longer way. It doesn't matter. Okay, but that is how that would work. Okay, guys, listen to me, please. These properties are so important. You need to know that when you're multiplying like bases, you write the base once and add the exponents. You need to know that when you're dividing like bases, you write the base once in the numerator and take the top exponent minus the bottom exponent. You need to know, and by the way, you can only use this property when it's one term over one term. You need to know that when a power is raised to another power, you multiply the exponents together. Now this only works when you have one term on the inside of the parentheses, okay? One term. You need to know that exponent sign, not the base, can be changed by moving the exponent and its base from the numerator to the denominator or from the denominator to the numerator. You need to know that. By the way, this only works when you're dealing with one term over one term. You need to know that anything to the 0 power equals 1. I hope this video has been a help to you. If you